Hello everyone, and welcome back. In our last session, we established the Analyst's Compass, your 4-level guide to answering business questions. Today, we're going to zoom in on the more advanced levels of that compass, the predictive and prescriptive parts. We're tackling Skill S52, which is all about applying a range of advanced techniques to quantitative data to find and predict patterns. I know the list of terms in this skill, data mining, forecasting, modeling, can seem intimidating. My job today is to demystify them and show you that they are the next logical step in your journey. Let's use an analogy. When you first learn mathematics, you start with arithmetic, addition, subtraction, to describe the world as it is. But to solve more complex problems, you learn algebra and calculus, which allow you to model relationships and predict change. This skill is the same. You've mastered the arithmetic of data, now we're going to give you the tools for the calculus. Our goal is to make these advanced concepts clear, practical, and directly relevant to your work. Let's use my scaffold and ascend method to break this skill down into a simple structure. Think of this as a guided tour of your new, advanced toolkit. First, the skill specifies that we are analyzing quantitative data. This is our focus today. We are dealing with numbers, things you can count or measure, like sales figures, website visits, or customer satisfaction scores. Next, it lists the tools in the kit: data mining, time series forecasting, algorithms, statistics, and modeling. I want you to see these not as scary, abstract concepts, but as specific tools, each designed for a particular kind of job. A hammer and a screwdriver are both tools, but you use them for different things. It's the same here, and we'll look at each one. Finally, the skill tells us what we are using these tools for, to identify and predict trends and patterns in data. This is the goal. We use these advanced methods for two primary reasons: to look back at our historical data and identify complex patterns that aren't obvious on the surface, and to use those patterns to look forward and predict what is likely to happen next. It's about moving from hindsight to foresight. Let's focus on why this is so important for your career goals. I know many of you are looking for a clear, predictable path to a more senior role. This skill is that path. First, it's about answering harder, more valuable questions. As a data analyst, your core value comes from the quality of the questions you can answer. Descriptive analysis, which you've mastered, answers the question, what happened? These advanced techniques allow you to answer the much more valuable questions: why did it happen, and what is likely to happen if we continue on this path? Second, it's how you become a proactive, not just a reactive, analyst. A junior analyst is often tasked with creating reports on things that have already happened. A senior analyst uses these predictive techniques to warn the business about problems before they happen, or to identify opportunities before they are obvious. This makes you a far more strategic and valuable member of the team. Finally, I want you to see this skill as your personal learning curriculum. It gives you a clear, structured path for your own development. You can focus first on deepening your understanding of applied statistics. From there, you can move on to time series forecasting. After that, you can start learning about building predictive models. It's a logical progression that takes you step by step from where you are now to where you want to be as a senior analyst or data scientist. Let's start with the foundation of all these advanced techniques: applied statistics. The principle I want you to remember is that statistics is the grammar of data. It's the formal set of rules we use to make sure that the conclusions we draw are robust and mathematically sound. It's how we separate a real signal from random noise. The analogy is a doctor looking at blood test results. A single reading that is slightly high might not mean anything, it could be a random fluctuation. But if they see a consistent pattern of high readings over time, and a statistical test shows that this pattern is highly unlikely to be random, then they can make a confident diagnosis. For you as a data analyst, there are two key areas of statistics to master. First, the descriptive statistics we've touched on before, calculating the mean, average, median, middle value, and standard deviation, how spread out the data is. This is your first step in understanding any dataset. The second, and more powerful, tool is hypothesis testing. This is where you use a formal test, like a t-test, to answer a question like, we saw that sales were higher for Group A than Group B in our test. Is that difference real, or is it small enough that it could have just happened by chance? The next tool in your advanced toolkit is one of the most practical and frequently requested: time series forecasting. The principle is simple: we use the past to predict the future. This technique is specifically for data that is a sequence of measurements over time, like daily sales, weekly website traffic, or monthly customer sign-ups. A perfect analogy is predicting the tides. We can look at the data for the tides over the past year, and we will see a very clear, consistent, and repeating pattern. The forecasting model learns that pattern, and it can then extend it into the future to predict, with very high accuracy, what the tide will be doing at any given moment next week. As a data analyst, there are three key concepts you need to understand. First is the trend. This is the long-term direction of your data. Are your sales, on average, slowly increasing or decreasing over the last 2 years? Second is seasonality. This is a regular, repeating pattern. For example, a retailer's sales will always have a huge seasonal spike in December. Your model needs to understand this. And finally, there's the forecast itself, the output of your model, which is its best guess for the future, based on the trend and seasonality it has learned from the past. Now let's talk about data mining. This is a broad term, but for an analyst, one of the most useful techniques within it is called clustering. The principle of clustering is to find hidden groups in your data that you didn't know existed. This is different from the filtering and segmentation we did in diagnostic analysis, where you were testing your own ideas, e.g., let's look at the North region. With clustering, you let the algorithm find the groups for you. A great analogy is a supermarket manager looking at all their loyalty card data. They have millions of customers and they don't know how to group them. They can use a clustering algorithm, and it will automatically analyze all the purchasing data and might identify 3 distinct groups. Group A are weekend family shoppers who buy lots of fresh food on Saturdays. Group B are weekday convenience shoppers who pop in for a sandwich at lunchtime. And Group C are evening wine and snack shoppers. The manager didn't define these groups, the algorithm discovered them from the data. This is a powerful technique for what we call customer segmentation, and it's a classic example of using an algorithm to find patterns you would never have spotted manually. Finally, let's look at the most advanced tool in our kit, modeling. The principle of a model is to create a simplified mathematical version of a real-world process so that we can make a specific prediction. A perfect analogy is a car insurance pricing model. The insurance company has historical data on millions of drivers. Their model learns the mathematical relationship between a driver's characteristics, like their age, the car they drive, and where they live, and the likelihood that they will have an accident. When you apply for insurance, they feed your data into this model, and it produces a prediction of your risk, which in turn determines the price you pay. As a data analyst, there are 2 main types of models you will start with. The first is regression. This is what you use when you want to predict a specific number. For example, you could build a regression model to predict a house's price based on its size, number of bedrooms, and location. The second is classification. This is what you use when you want to predict which category something belongs to. The classic example is an email spam filter. It analyzes an incoming email and predicts whether it belongs to the category spam or not spam. Let's walk through a complete, end-to-end example of how you would use one of these techniques. The operations manager comes to you with a problem. We keep running out of stock of our most popular product. Can you help us predict future demand so we can order the right amount? You immediately recognize this as a forecasting problem, which gives you a clear, structured path to follow. First, you get the data. You write a SQL query to get the last 3 years of daily sales data for that specific product. Second, you select the technique. Because this is about predicting a future value based on a sequence of past, time-ordered data, you know that the appropriate tool is time series forecasting. Third, you perform the analysis. You load this data into a tool that has a forecasting capability, like a Python library or a feature in your BI tool. The model runs and analyzes the historical data. It automatically finds the 2 key patterns, a slight upward trend in sales over the 3 years, and a very strong seasonal pattern, a big spike in sales every winter. Fourth, you deliver the prediction and your prescriptive recommendation. The model uses the patterns it has learned to generate a forecast for the next 3 months, which clearly shows the winter spike is coming. You don't just show the manager the chart. You translate it into a clear action. You say, the forecast predicts a 40% increase in demand over the next 3 months. I recommend we increase our next stock order by 40% to prevent a stockout. You have used an advanced technique to provide a direct, valuable, and proactive solution to a business problem. Okay, it's time to practice thinking like a predictive analyst. This portfolio task is designed to show that you can identify opportunities to use these advanced techniques in your workplace. You don't need to do any complex maths, you just need to create the plan. I want you to think of a number in your business that is measured regularly over time. On a single page, I want you to create a predictive planning document. First, state a business goal that could be helped by a prediction. For example, to make sure we always have enough staff in the customer support team. Second, identify the specific metric to forecast. For example, the number of new support tickets we receive each week. Third, name the analytical technique that would be appropriate. In this case, it would be time series forecasting. And fourth, describe a potential prescriptive recommendation you could make. For example, if the forecast predicted a large spike in tickets during the first week of December, my recommendation would be to ensure no one from the support team is on holiday that week. This simple, one-page plan is perfect evidence that you understand how to apply these advanced analytical techniques to solve real, practical business problems. And that brings us to the end of our session on your advanced analytical toolkit. The key takeaway is that these techniques are what will allow you to provide a new level of value to your organization. You will be able to move beyond being a historian who reports on what has already happened and become a futurist who can provide a data-driven glimpse of what is likely to happen next. You now have a clear, structured understanding of the main tools in this kit: statistics for rigor, forecasting for time-based predictions, clustering for finding hidden groups, and modeling for predicting specific outcomes. This is your path forward. I would encourage you to start your practical learning journey by focusing on applied statistics and time series forecasting, as these will provide the most immediate value in your role. By mastering these skills over time, you will be able to answer the most challenging and important questions the business has. You will become a trusted, strategic advisor, and you will have a clear and predictable path to the senior roles you are aiming for. Thank you for your focus today. Thank you so much for joining me today. I hope you now feel more confident in mastering this topic. If you found value in this session, I have a small favor to ask. Please hit that subscribe button, give this video a like, and follow our channel. It really means a lot to me and helps the algorithm show these lessons to other apprentices just like you who need support. Don't forget, you can download today's slides and the full transcript at www.mentorinai.com EPA Hub. While you are there, check out our mock interview and portfolio review services to make sure you are fully ready for your EPA. See you in the next video. Keep learning.